Hello, I hope you're all well. Welcome to this, our penultimate live stream. We've done 24, this is the 24th one, 25th next week, and then we've got a sort of a quiz at the end of it. So I hope you're all well, hope you enjoy your holidays. Sorry for the mix up last week. I had apparently tried to book one of these for half term, sorry, for the Easter holidays. It wasn't going to happen, so we're back today anyway. Please do introduce yourself, and I shall welcome you to the live stream. So today's one's actually quite easy, and I quite like today's topic because it gives you a chance to, I think, get some marks in paper two, some easy marks for paper two. I wouldn't say it's the most exciting of topics, this, but it's an easy way to get marks because it's just describing the product that you use in order to write code. So it's easy peasy, really. So before we go any further, let's step back and have a look at what came before and do a bit of pre-quizzing. Aditya, hello, dear man. How are you? Thanks for coming. Et bonsoir aussi. Hi, Bogdan. I hope all is well. So, quiz time rewind. This should be dead easy for you guys. Hi, Flynn. How you doing? Thanks for joining in tonight. Okay, what about this one? This one goes back to Boolean logic, which I always think is quite an easy one. Well, it's logical, isn't it? What about this? If the inputs to an AND gate are 0 and 0, what are the output? Easy peasy. And Aditya has come in with 0, and I think we can... we've got Bogdan with 0. So you guys, and we've got Flynn with 0 as well. So that is 3 correct answers. So let's push straight on with the next one. They're all 0, so the answer is 0, clearly. Okay, so next question's this, which I hope you can read. That rewind is right over the key part. What output is missing from the truth table below? I can see an issue with my not very transparent rewind here. I think you can take it. It's the one just under the E there. That's where it's supposed to be. Any ideas? It's actually quite hard to see. It was a 0. So let's go on to the next one, which I don't think I've... Oh, that's better. So look at this image. What type of logic gate does this symbol represent? Obviously, just find a way of learning these rather. Bogdan, you were absolutely spot on. I've whizzed on because I put it rewind right over the top of the answer, which was pretty stupid of me. It is, it is Bogdan, an AND gate. You are a superstar. Only 3 to learn. Just make sure you're happy which is which. All right, let's not muck around then, and let's push on. What about this one? Oh, that's right. I'd actually by this time sorted it out and made my rewind slightly transparent. So what output's missing from the truth table below? Now they might add one more level to a truth table like this. So have a bit of practice to make sure that you can draw a trace table from one of these diagrams. Aditya is saying 1. And make sure that, because basically they could also give you P equals not A and make you draw that. They'll go to one more level of complexity. Bogdan has come in with 1 as well. So I'll tell you what, let's put you out of your misery. The answer is 1. So that is a double ding for that. Outstanding chaps, well done. What about this one? What does it represent? What's this one? I always think it's a slightly more difficult job is to actually build the, maybe not in this case, but if they do it to 3 levels of complexity, it's slightly more in terms of building an expression out of this. What does it represent? That's the question. What does it represent? Any ideas? And I think have a look back at the examples from last week. I'll put them on the system for you. We've got Bogdan. There's obviously a glitch. It must be with YouTube that the brackets come out as smiley faces, because Bogdan's come out with admittedly, where is it? Bogdan's come out with a more exciting piece of code. C equals not A and a guy wearing sunglasses. Aditya's come out with C equals not A and B. And Hash Brown, hello dear man, I hope all is well. Hash Brown, C equals not A and B. Shall we see how you did with that? The answer was C equals not A and B. So just the brackets that were missing there. And Aditya, that was spot on for you. and Bogdan, that would have been spot on had the man in the sunglasses not got in the way. So yeah, that's all pretty sorted. You're happy with those? I reckon they're going to have something like this in the exam. I think they're going to put one of these in, or they're going to make you build it from a more, from an expression. I think this is what they'll do. So how do we feel about this one? I think when you get to 3 levels, it's a question of thinking about how you're going to build it and sort of working maybe from the inside to the outside. So what about this one? What do we think? I'll give you a moment or two to consider this one. So Ditya's gone for D equals C and A and B. The good thing is starting with D, because that's where the output is. Hang on, we've got C, not C. D equals not C. Okay, yeah, I got it. Hash Brown's gone for D equals not C and A and the man with the sunglasses. Bizarre, that, isn't it? It must be a keyboard shortcut that picks it up there. So should we have a look and see how that one has panned out? Tell you what, let's put up the ones we had before, because you said that it was D equals not C, A and B, so that was looking pretty reasonable. Hash Brown, you had D equals not C and A and C, that would have been, that was pretty good. And Bogdan had D equals not A and B and C. So this is good. You've got a handle on this. Yeah, it's a weird one, although that made it slightly more exciting than the guy in the sunglasses. So again, if one of these pitches up in the exams, you are in a really good place for it. So that's all good. Where are we? 6 minutes gone. Seems to be the way that it works. Right, programming languages and integrated development environment. I think the biggest issue with this topic is to figure out how to learn these lists of different features and functions, which is really all that we're looking at here. So looking at the specification, characteristics and purpose of different levels of programming language. So we'll look at high level versus low level languages first, and then we'll look at translators and the 2 flavors of translators, the compiler and the interpreter, and the benefits, and I guess the benefits and disadvantages and the characteristics of both. All right, so that's the high level, low level translators, and then looking at translators, we're going to look at 2 types, compilers and interpreters. That's the grand plan. Easy peasy. So first of all, we know that when you write code, so stepping back even one step further, is that programming languages are used to implement languages, to implement algorithms. So you would write an algorithm, and the programming language is the tool which enables you to bring that algorithm to life, if you like. And you've got 2 main categories of programming languages, high level and low level. Now, the high level one is like Python, C#, Java, all the ones that you would use to write, whether it's a web app, whether it's creating something like Word and an application, whether you're writing a game. And obviously different types of languages have got different types of benefits and suit different applications. So you would choose one that's going to best suit what you're trying to do. But say, for example, something like Python, you can pretty much turn that to most things, which is why it's become such a popular language. And then you've got low-level code like assembly code, C, and machine code. And machine code, which we'll get onto next. The thing about machine code is that is what the only thing that the CPU understands. Now, I actually hate the way that we talk about computers understanding code, because they don't understand it. They simply translate it, they interpret it, they execute commands based on it. There's no understanding involved, but it's difficult to find out another way of expressing it, really. So high-level languages. Let's look at the advantages, okay? So high-level languages are easier for humans to understand. Obviously, if you had to write code in binary, it would be horribly complicated. Imagine trying to find a mistake when you're writing just long strings of binary numbers. I mean, you could do, but it would be extremely difficult, extremely tiring. We talk about the code being maintainable, so you can hand it over to someone else. So clearly, a better system is to have it as a high-level language, because it's easier to understand. It uses English words. It says words similar to English. They are English words that they use mainly. And it's easier to maintain and read than low-level languages. So it means the code could be handed on to someone who's going to write an update for it after you've left the company, and they can do it more easily using a high-level language. The other advantage of a high-level language is it can be translated for multiple machine architectures. So whether you're looking at Mac or PC, or whether you're looking at tablets, or whether you're looking at phones and the different phone types, high-level language can be pushed out across all of them. And if you've used something like, I suppose another example would be that when you write a website in something like Dreamweaver, which is a web creation tool. It's called a WYSIWYG. What you see is what you get is what the WYSIWYG stands for, editor. And once you actually export it, you'd export it for mobile, you'd export it for tablet, you'd export it for Windows or for PC. Okay, across different platforms. So these high-level languages are quite easy to learn, and therefore it makes the code more maintainable. It's worth spending a bit of time with this particular page. Let's have a look. Hash Brown's asking me a question. Are there high-level languages speak at different, for example, do they have Spanish Python? No, I think is the answer to that, because Python, no, it's in order to program, you would need to be able to speak English. Or that's not true, actually. You would need to know what the equivalent terms meant. So, so I mean, say, for example, if you're programming in, if you're a Spaniard programming in Python, idle, all of the help functions, all of the soft stuff around you would be in Spanish, so that would help you. But the actual code itself is going to be in English. Yeah, that's an interesting question. No, it'll be the same. C is going to be it's going to be in English. But don't forget, it's not all English. Some of it are command words, which are not always English. Okay, yeah, it's a good question. I totally agree. It's not that's not how it would work. So translated across multiple machine architectures. Now here's a bit of vocab for you. A program written in a high-level language is known as source code. And we've got source code versus machine code. So source code is that which is written in a high-level language like Java, Python, etc. Okay. Now in this particular on this particular screen here, you've got some advantages of why high-level languages are useful. Okay, that they can be applied across many types of architecture. They're easy to learn because many of the words are English words. They're easy to maintain. So think about pulling out the bonuses for using a high-level language. Is compiled code the same as machine code? Yes, we'll get to that in a second, but the short answer is yes. Compiled code is machine code. That's a good question. That means the next. That means this was worth doing, which is going to be handy. Let's see if I answer this in the next minute or two. So we've talked about high-level languages, right? Java, Python, C, the sort of programs that the sort of high-level languages you would use to create anything. So anything that you use, any game that you play, any application that you use, any web app that you use, any phone app that you use, it's been written using a high-level code. That's how everything's done now. Now let's look at low-level languages. Low-level languages are closer to what machines understand. Again, it's that word understand. We know that the CPU can only understand binary. Everything that the CPU actually does has to be in binary. Anything that goes into the CPU has to be in binary, and machine code is binary. Now, the problem with low-level languages, because there are low-level languages, because don't forget that there are low-level languages which involve more binary, and which are closer to binary, but they're harder to code and they require more instructions. But you can directly interact with memory. But when you work in this way using a low-level language, they only work for a certain type of machine architecture. So you'll be writing it for a particular type of machine architecture. And we've got machine code and we've got assembly language. Now, assembly language was used until, I don't know, 20, 30 years ago. People would use opcodes. And these were opcodes, for example, like there'd be a binary code for load, a binary code for store, a binary code, a binary code for each and every single item. So if you learnt those binary codes, you could actually program quite quickly. But it's very easy to make mistakes, very easy to lose yourself, and it doesn't make the code very maintainable. So can you see that I'm going back to that maintainability of code thing? So that's when you're sort of saying about the benefits of a high-level code. It's much easier to maintain. We'll talk about why in a minute. So machine code, it's just zeros and ones. Assembly language, again, it's still looking at binary, but there are some English words in there. Sort of some shortcuts for load. So it's not all binary assembly language, but machine code is. Okay, machine code is the only thing that the computer can understand. And it's worth bearing in mind that each CPU is going to have a different set of it's going to interpret things in a slightly different way based upon its firmware, isn't it? So the as each new family of CPUs grows and they release newer and newer CPUs, they're always trying to improve the way in which a CPU actually works. All right. I think that's the word possibly that I was looking for. It's certainly better than understand, because understand is a rubbish word for it, because and I know, yeah, because computers don't understand anything. So using the word understand, it's like when at Key Stage 3 you're always taught that the CPU is the brain of the computer. It's not a brain. It's nothing like a human brain. It performs some of the same functions as a human brain. I guess you could say we've got a longer term and a shorter term memory. For example, you might learn a phone number and sort of rehearse it in your head because you've got to use it there and then, and 10 minutes later it's gone. And we can look at ways of putting things into sort of longer term, trace memory versus longer term memory, but it's just not really very helpful. Where are we? 47. So translators. We'll get into translators now. Now, translators is this idea of taking what's in a high-level language and turning it into a low-level language that the CPU can actually understand, okay? So we know that computers can only, and we're going to use Flynn's word interpret, the CGP guide. Yeah, I know. And I wouldn't mind if that CGP guide was the Key Stage 3 one, but they're caught between two places because they're trying to think of a sort of a way of explaining the CPU so it makes sense. But it's literally a machine which fetches, decodes, and executes instructions. I can even take away the word literally. It is a machine that fetches, decodes, and executes instructions. Billions of times a second. That's all that it does. So yeah, let's stick with Flynn's interpret, because I like that, Flynn. That's good work. Computers only interpret machine code. Machine code is written in binary, and the source code, that Java or Python's got to be translated into machine code. And it can do it in two ways. So we've got two types of translator, compiler and interpreter. Now, actually, this is quite straightforward in the sense that one, you would use to, once you've got your program, once you've got your code working exactly as it should, it's got no errors in it, you would use one of these, and then you would create, in the case of Windows, a .exe program, an executable file that you would then double click on, and it would open and it would run. In the case of Mac, it's a DRM file, in Linux it'll have a different file extension. So let's look at this one. This is the interpreter. The interpreter, on the other hand, is used when you're writing code. It's a way of writing code more effectively, and this is how it works. So you've written your code using your IDE, but it's called idle. They try to be funny with Python. Eric Idle's a Python, so it's called idle. The Python version, the Python IDE. And once you've written your code and it works, you've got no mistakes in it, this is what happens. The interpreter translates the code line by line. It reads the line, it translates it, and executes it. But if there's an error, it's very, very important there are no pigeons in the garden. You'll be glad to know there are no more pigeons in the garden. I don't know why they bother chasing it. They get nowhere near the pigeon any time, but you'll be just reassured to know that there's no birds in the garden now. So if an error occurs, the program stops straight away and the error is highlighted. And of course, why does it do that? So you can fix the error. That's why it's done. Hello, Swiftblade. How are you? Thanks for coming along, dear boy. So the bonuses, because they might go for an advantages, disadvantages of interpreter, compiler, so they'll want to know, do you know what the difference is? And then they'll want to know, do you know what the features are? And they'll want to know, do you know what the advantages, disadvantages are? 10 minutes to go. An interpreter requires less memory. It must be installed on every machine. That's a negative. And the source code is required each time, okay? So that's the advantage of the interpreter over the compiler. So you use an interpreter when you're writing code to find mistakes. And once you get all of that sorted out, you then go on and you use the compiler. So interpreter, then compiler, all right? And you find a way of linking into your head how the compiler is the final version and the interpreter is the thing. If you think about a language interpreter, think about when you see these political summits and you've got people with their earphones in and the interpreter there is doing the sort of the hot take on what they're saying, translating it word for word. So compiler, it takes all the code you've written, it translates it into one go. It creates an executable file, which I struggle to say clearly, which is a .exe file. That's the file extension. The code's optimized. Debugging is obviously harder because you then run the program and it would run to a point and then say error at line 463, and you'd go, oh, right, go back to your IDE. So that's no way to try and fix a program. Only once you think it's working would you want to compile your code. Only works on specific architectures and requires more memory. So those are your pluses and minuses of compilers. Just make sure you're happy with that list of pros and cons for compiler versus interpreter. So level 1, do you understand why they're needed? Level 2, do you understand the difference between the two of them? And level 3, do you understand the advantages and disadvantages of each? Boom. Okay, so now let's look at the IDE. In Python's case, this is idle. It is the interface, the piece of software that you use to write code, which you've all had to go at anyway. Not as much time as we'd like to, but we can thank COVID for that. So it's the software that's used to write programs. And what does an IDE provide you with? It provides you with a code editor, error diagnostics tools, so ways of finding mistakes in your code, a translator that we just talked about that's going to tell you line by line where your mistakes are, highlight them, offer you alternatives, try and help you and say, it's like a spell check, isn't it? And a runtime environment, which means you are able to run the code inside the program. Yeah, so that's what you can do with an IDE. And I'll make this available to you, so don't stress too much about writing anything down. So tools and facilities. So I guess these are the features of an IDE. So if you were selling an IDE to someone, you'd say it can do this, and it does this, and it does that. So these are the features, and you kind of need to have a bucket load of these. I think I've got 6 up here. And if you go in with the knowledge of these, there could be a sneaky 6-mark question where they say, they sometimes say color coding is one of the features of an IDE. Can you name another 3, 4, 5? Okay, so just be aware that could be thrown at you. Color coding, error checking, bracket matching, autocomplete, auto indentation, and version control. So I think most of those are pretty self-explanatory. We've talked about indentation, and indentation is obviously where if you've got a piece of code down here, it will move in. No, that's the wrong way. Let's go this way. It'll move in. There we go. To make the code easier to read. You know, like we would nest if statements, and we would nest them in and in and in. Okay, so autocomplete. So it'll offer you helpful suggestions, which should make the coding a bit quicker. Okay, so those are some tools there. So what does a runtime environment allow you to do? It means that you can run your code inside the computer. And it runs the program without having to compile it. Because obviously if you were using a compiler, you'd have to write your code, compile it, run the exe file, find a mistake on line 6, go back and do your coding again, compile it again, find a mistake on line 57. It would drive you mad. So that's why it's so useful, okay? So these are some more tools that you've got. You've got syntax checking, which is sort of a spell check, but obviously the syntax in terms of the of the code in which you're writing into, whether it's C, whether it's Python, whether it's Java, line numbers, which is always helpful. Otherwise, you don't know where it is your errors are. Variable tracing, so you can trace your variables across the program. Breakpoints and stepping. All right, I need to get a move on. So quiz time. I hope that has made some kind of sense to you. I think that this is a they're going to put something in there. I mean, paper 2 is the least certain paper for you because they've not taken anything out of it. So I think we can expect a paper 2 that's looked like every other, but they do like a question on this. The cynic in me says, because it's quite an easy one to ask questions on, because these are several sets of lists that you've got to learn. So just make sure you go back and have a look at these lists and you're happy with source code versus machine code. You're happy with compiler versus, that you're happy with the two different types of translator and why you would use one over the other, okay? And that's the important thing there. All right, what about this? Look at the table below. What type of translator is described in column A? What type of translator is described in column A? Ah, hello, Sergen. Yes, it indeed is an Arsenal shirt. There we are. I shall It's a rather strange yellow shirt, this one. It's a rather unusual yellow colour, but they're always quite nice to wear in the summer, football shirts, in spite of the ludicrous price. Compiler, so says Aditya. Hash Brown has also come back with compiler. Good to see you, Sergen, by the way. I hope you're doing well. It was quite an impressive destruction of Everton the other day. And the answer is compiler. That was outstanding, chaps. Well done. That is very, very good indeed. Bogdan also came in with compiler. That was very good. And Sergen came in with compiler 2. All right. So we're happy with that. All right. What about this one? An interpreter will stop once it finds the first what in the code. Pigeon. Oh, the pigeon has landed back on the fence, just to give you an update. So there could be another mad dash for the dogs. Aditya's gone in with error. Bogdan's gone in with error. Hash Brown's gone in with, yeah, you've absolutely nailed it. And Sergen said error as 2. Yes, of course it is. It's the error or bug. Outstanding. Several dings for that. Okay, high-level code usually only works on one type of machine. High-level code usually only works on one type of machine. True or false? Bogdan has said false. Anyone else? Sergen said A. Oh, okay, and Aditya said A, sorry, which is false. And Hash Brown said A. I should pay more attention. Okay, so that is looking pretty good. Hash Brown said A. It is false. You're all absolutely spot on. Okay, how long have we got left? 2 minutes left. I'm going to finish on time, though. What have I got? So let's get a move on. A translator in an IDE is needed to translate high-level code to what? Make sure you know the difference between these two. This is expected knowledge, this. Translator in an IDE needs to translate high-level code into what? Dun, dun, dun. Any ideas? Hang on, so we've got Aditya with A. We've got... we've got Bogdan saying machine code. Yeah. And we've got Hash Brown saying A as well. It is machine code. You're absolutely spot on. Let's try and get this through. There we go. That is Sergen saying A as well. Well done. Yes, guys, you're all spot on. Right, where are we? I've got... Yeah, we'll get this done. 1 minute. For which of these is not a feature of an... is not a feature an IDE might have for helping programmers to find and fix errors? That's a mouthful. Which of these is not a feature an IDE might have? Debugging tool, logic checking, or error diagnostics? What do we think? Which would you not find in an IDE? Aditya has said B, Bogdan has said B, and you are all, Hash Brown said B as well. You're all absolutely spot on. And Swift Blake came in with B as well. That's exactly what it is. So, and Sergen did B as well. So that is all spot on. 1 minute to go. Let's get this done. Question 6. One way a that code editors can help programmers write code is by displaying strings, functions, loops, variables, comments in different beep. What word completes the sentence? What is the blank? What's the blank? It's 7 o'clock. I've only got two more. I've only got one more question after this, which I think we can just nip through very quickly. Aditya has said lines. Shall we see straight away what it is? The answer is colours. Okay. Let's push on and do the last one. This is 41. Oh, this is me talking about next time. It was indents. Oh, hello. This is a bit random. That shouldn't even have been there. So that saved us time. There we go. We are at the end. It's 7 o'clock. Woohoo! So listen, next week. This is the one where I was ill at the very start. Do you remember? I missed one back at the very beginning in 1.2.5, sort of 20-something live streams ago. So need for compression, lossy and lossless. We'll do that next week, and then the week after we'll do a final quiz, an amalgam of all the different sort of quizzes we've done, and then we are all done, guys. It's 7:01. I must go. Thanks for coming today. Have a lovely week, and I will see you same time for the penultimate computer science live stream next week. See you guys. Take care. Bye bye. Bye bye.